Awesome. So we're going to try that. We're going to try to expand our expression that we've created. So we've got x plus 1 times x plus 2 times x plus 5. We're going to tackle that the same way we tried to multiply things before, where we said, do we multiply the first things together, get an answer, then multiply the next things together. It's just now we're doing with polynomials, so it's a little bit more challenging. I'm going to just do the first two, because I think it's easier to just do the first two. So if you look, I'm going to multiply these guys together first. When I multiply those two guys together, I've done a lot of distribution, so I'm going to do an area diagram for this guy. I would get x squared, x, 2x, 2. I would get those four terms. X squared, x, 2x, 2. When you write them all out, you combine your like terms, you would get x squared plus 3x plus 2. Okay, so I combine my like terms, which is 2x plus 1x. Length times width equals this guy right here. It equals x squared plus 3x plus 2. That's this thing right here. If you want to get volume, you need to do length times width times height. So what we do is we go back up to here and we realize now I have to take my answer and multiply it by x plus 5. Right, I'm not done yet. I've only combined the first two polynomials, length and width. Now I multiply by my height. When I multiply by my height, I can use any strategy I want. We just did an area diagram, so let's do distribution. Distribution would look like this. The x comes in 3 times. That would become x cubed plus 3x squared plus 2x. And then I would distribute the 5 in. We go plus 5x squared plus 15x plus 10. Whichever method you chose, you would end up with those 6 terms. Your last step is to always combine like terms, right? We multiply together, we combine like terms, meaning same letter, same exponent. We have an x cubed there. We have 2x squared. 3 and 5 would be plus 8. 2x plus 15x is plus 17x. And then plus 10 would be the last thing. That is my final answer. If you look at the question, it told you that when you're done, you should have this form. Some number times x to the power 3 plus some number times x squared plus some number times x plus a number. That's exactly what I got. I have an x cubed, I have an x squared, I have an x, and I have a constant. So my answer matches the form that they said it would be in. That's helped us just to kind of clarify and make sure we did it properly. Awesome. There's 2 questions. They're the last 2 questions, I believe. Let me just take a look. Yeah, they are. Try to multiply those things together. So give it a shot. All right. Let's look at these. So, when you multiply them together, I would do the first 2 binomials together. I do x minus 3 and then x plus 4 and multiply them together. When you multiply them together, using whatever system you want, you should have got x squared plus 4x minus 3x minus 12. You then would combine like terms, right? Those middle terms would become x squared plus x minus 12. You still would have this 2x plus 1, sorry, 2x minus 1, sitting there on the side waiting to be multiplied in. Right? But you can't multiply the third thing until you've multiplied the first two. When you multiply these two things together, whatever method you used, you should have ended up with 2x cubed plus 2x squared minus 24x, and then minus x squared minus x plus 12. And I'm just using distribution. That's how I'm getting those things. Just doing it in my head, not showing it with the little rainbows. Either way, you should get the same 6 things. Maybe not all in the same order, but the same 6 things. Your last step would be to combine like terms. That means x squares with x squares, x's with x's. Okay? When you do that, your final answer is 2x cubed plus x squared minus 25x plus 12. My reason being, when I combine my like terms, 2x squared minus 1x squared is positive 1x squared. Negative 24x minus 1x is negative 25x. Remember, there's invisible ones in front of things. So if there's no number there, it's an invisible 1. Awesome. That should have been your final answer. The next question is the same as the first question, but in a different order. If you look, x minus 3, x minus 3, 2x minus 1, 2x minus 1, x plus 4, x plus 4. It's the exact same binomials, just in a different order. When you multiply them together, did anybody notice something about their answer compared to the first answer? So when you multiplied b, and you got an answer, and you compared it to your first answer, did you notice anything? Uh-oh. Okay, let's try it. Let's see what happens. So if you multiply the first two binomials together, the look of no confidence out there, always very reassuring. So if you multiply the first two binomials together, you would have got 2x squared, and then you would have got minus 6x, you have minus x, you would have got plus 3. Okay, that's the first two binomials together. When you combine your like terms, right, you get 2x squared minus 7x plus 3. Those numbers are drastically different than when we multiply the first two things together over here on the left, right? We had x squared plus x minus 12. Now we have 2x squared minus 7x plus 3. Looks completely different so far. This x plus 4 is still on the end. And again, you're going to have to do distribution or area diagram. When you do distribution, which is what I'm going to do, I end up getting 2x cubed minus 7x squared plus 3x. Then I distribute the 4 in, I get plus 8x squared. I get minus 28x. And I get plus 12. Now if I look, I have 6 things. Those 6 things still look very different than the 6 things I got on the first question. However, I do have some like terms here. Right? I have x squareds that need to go together, and I have x's that need to go together. When I combine those, I get 2x cubed still. I get plus 1x squared. I get minus 25x. And I get plus 12. Now if you compare your answer to the first answer, you'll notice that they're the exact same thing. The reason they're the exact same thing is multiplication order doesn't matter, right? So 2 times 3 times 4 is the exact same thing as 4 times 2 times 3. It is the same thing. So when you see something like this, if there's 2 that you would prefer to multiply together first, do those 2 first. The order doesn't matter. I always just do first 2, get an answer, multiply by the third one. But in reality, you could do any order and it'd be the exact same. Awesome. Tomorrow, we're going to do